Hello everybody, Danny Jenkins here from ThreatLocker. First of all, there's really four components to ThreatLocker, and each component goes a little bit further to getting to a true zero trust architecture. The idea of zero trust is essentially we change the dynamics from trying to look for threats and trying to block threats based on either known suspicious behavior or trends that look like threats to blocking by default. The first part of that is what's often referred to as application whitelisting or default deny. Essentially, what we're saying here is nothing can run unless it's trusted. Now, the idea of that often seems terrifying to people, but if you think about it, that businesses don't change what they do on their computers. So most companies across the board run the same set of applications. They run Google Chrome, they run Office, they run some custom healthcare apps or line of business software. But that list of applications doesn't change. And when it does change, it tends to be inside the boundaries. So maybe Joe in accounts is using Grammarly and then Sandra wants to use Grammarly. So they tend to be pretty standardized. What ThreatLocker's done is made this concept of zero trust really easy. And there's a few different challenges we set to overcome and that we did overcome. The first one is the deployment and the implementation of it, because you can't just roll out an agent and say tomorrow, okay, nothing can run unless it's trusted. So first thing that happens when you deploy ThreatLocker, it's going to go into this learning stage. What the learning does is say, hey, this is what's running on your computer. Let's audit everything that's happening. We're not going to block anything at this point. We're going to audit every application, every DLL, every script file that runs, and we're going to put it in this centralized unified audit. Within a few minutes of installing, you can see this data. Now, the data includes things like who it was signed by, what the name of the vendor is, what the hash of the file is, things like that. But it's really useful for two reasons. One is the reason you never want to use it for is a forensic log. So if something happens in your environment, you can see everything that happened and who it happened with. The next thing is creating that set of policies. And that's what we really want to use it for. We want to automatically build policies based on this data. So if you're running Firefox, we create a policy for Firefox. If you're running Notepad++ or ShareX or 7-Zip or Hashtab or Dropbox or Zoom, we'll go off and we'll create all these policies for you out of the box. Now, after a learning period, which is typically 7 days, what you can do is you can review these policies. If there's something you don't like, you can set those policies to deny. So if you find Dropbox is on here and you don't want Dropbox, you can deny it, or you can edit it and allow only certain users to run it. Once you're happy with that, you can do a quick review to make sure nothing's going to go wrong, because I understand everyone's a little bit concerned. So you can go into the unified audit. You can filter by anything that would have been denied in a certain period of time. So if you let it learn for 2 weeks, you could essentially say 10 days of that is what we call a look back period. Let's simulate our denied environment to see what would have been denied. If there's any exceptions you need to create, you can create them up front at this point. If there are, they tend to be few and far between. Once you're happy with that, you can simply go to the computer's page and switch this to secured or just enable protection on all of them. The next thing that happens is within about 60 seconds, your machines are now going to be locked down. So if somebody downloads a piece of ransomware, whether it's through the kernel, whether it comes out through your RMM, SCCM, Active Directory, or whether a user tries to download it, they open a Word document, it downloads something and tries to run it. If it's not on that list of allowed programs, it's not going to be allowed to run. So when they do try and open it, they're going to get a pop-up like this. Again, this is all configurable, but this is the normal environment. They can request access, and if you're an MSP, you can brand this with your own logo, and they can give a reason, and they can just request it. So in this case, I tried to run TeamViewer. Of course, we don't normally want TeamViewer running in our environment, but maybe this is an exception. I can go off and I can approve that app within 30 seconds, which is really, really cool because the user's not going to be waiting around. Now, the other thing is when we found those applications on your machine, we match them to known applications. So in this case, this matches TeamViewer. We have ThreatLocker has a built-in definition. It gives you the confidence it is what it says it is. It takes care of all the dependencies, but we're also going to track the updates of that application. So if TeamViewer updates tomorrow, we're going to say, hey, TeamViewer updated. I need to create an exception. ThreatLocker is going to monitor that, and we're going to make sure the new version of TeamViewer works as well. And that's not just TeamViewer, but Office and Chrome and Windows updates and Zoom and over 450 apps. Anything that you push out third-party patching through, we no doubt have a built-in app for that, and we're going to track it for you. You can very easily permit these applications. I'm going to get into the ring fencing in a moment, but I'm just going to show permit without restriction. We can do elevation. I'm going to talk more about that as well. And I can permit it for the entire organization. I can permit it across an entire MSP, or I can permit it for just an individual computer. In this case, I'm going to say for the workstations group in this company. Now that this has been permitted, within about 60 seconds, that application is allowed to run. And the user doesn't have to do anything else. It's just as simple. I can double click on this and you can see here, I'm not very patient. I'll give it another 30 seconds or so, or 5 seconds. We'll give that a second to take into account, but essentially we should be able to run that, no other action required. And you'll see here what it actually did in the background was it just created a policy to allow TeamViewer. I could edit that policy. I could get more granular if I wanted to, but in this case, I don't need to. And you can see I can now open TeamViewer. The other thing that's worth noting is the ring fencing part of this. So step 1 of zero trust is don't let anything run that isn't trusted. Step 2 is don't trust anything that you do run beyond what it needs to be trusted for, because every time you open a program on your computer, that application has access to all of your data. So if you download a game from the internet and you're playing that game and that game is rogue or malicious or even got a vulnerability, that game could be compromised and it could be used to extract all of your data. And often we see this in the weaponization of tools built into Windows. We see things like PowerShell being called from Office, or there was a vulnerability in Zoom that allowed you to run PowerShell from Zoom, or Internet Explorer had a vulnerability at the end of 2019. So we see people calling PowerShell, calling Redshift, calling RunDLL from your other applications. So the next thing we want to do with Zero Trust is start locking down those applications that are allowed to run. In the first case, I'm going to say, hey, I've got a policy for Office. What does Office really need to do? Well, there's different measures we can lock this down with, but at the very beginning, we want to think about how that application needs to talk to other applications. How does it need to talk to PowerShell, command prompt, C script? Does it need to open these programs? And in many cases, the answer is no. So what we can do is we can actually stop an application talking to other applications. This is really important with elevation as well, which I'll talk more about in the second video. So in this case, we're saying Office cannot call PowerShell. So if somebody opens an Office macro that tries to upload files to the internet, it's not going to be able to do that through PowerShell because we have that policy in place. This is an example of a PowerShell command. This PowerShell command essentially iterates through my documents folders and just uploads all my files to a Google storage device. I could call this potentially from PowerShell. I'll call it from command prompt here. I could call it from a vulnerability in an application. But if an application can't call another application, it stops it. In this case, I'm going to call it from Office. What it's going to do in the background, it's going to try and update everything to the internet or upload all my files to the internet. And because we have ring fencing policies in place, first of all, to stop that being launched, but secondly, to stop those applications doing more than they need to, we're able to foil that breach. So if I look here, and these are all out of the box standard policies, you can of course get more granular, you can get more effective. You see, so we saw it with SolarWinds Orion, where we were able to foil that breach because SolarWinds needed to be able to go out to the internet, but it didn't need to go out to anything but the SolarWinds servers. So when it was compromised and that in source code was embedded and it tried to reach out to malicious servers, it wasn't able to do that because we had a ring fencing policy saying, hey, SolarWinds can't go out to the internet. In this case, we're saying PowerShell can't go out to the internet except for Office 365. If we need to add an RMM in here, we can do. The next thing we're doing is we're saying the applications can't interact. They can't access any protected files. They can't access files on our network shares. That way, if the application is compromised, it can't eat our data, upload it to the internet, encrypt our files. It can't access the registry or change the registry. We can set this really granularly, or we can set this with effective templated policies that make it easy for you to lock things down. You'll see here that when PowerShell tried to eat my lunch, for example, there, and it's not just PowerShell, Redshift, RunDLL, these are all weaponizable tools. But when we see it tried to happen here, you can see it was ring fenced. All of these policies, all of these files, it couldn't get in there because these are protected files. PowerShell has no business talking to them. It couldn't do it. If it had been able to talk to them, it would have been stopped at the upload point as well. Ring fencing is really, really effective when it comes to stopping applications being weaponized against you, fileless malware, attacks that live off the land. Whether it's SolarWinds getting compromised or whether it's PowerShell, Redshift, RunDLL, or just a game that decided it was actually going to steal your data for the benefit of using that free application. all of this is going to be able to control, and it's really easy to make exceptions. So if you do need PowerShell to talk to one network share, let it do that. Then today I want to talk about two more components that are going to help us achieve that zero trust goal. The first one is storage control. How can we implement security around storage? And I don't just mean USB drives. Controlling USB drives is important, but it's not the only storage device we have to worry about. Network shares, data shares, documents folder, all of these are storage devices. They all contain data, backup shares. We want to protect that data from encryption. We want to protect that data from ransomware. We want to protect it from being uploaded to the internet. So what we're going to do is we're going to show you how you can harden your environment and how you can stop these being used against you. So first things first, ThreatLocker storage control, the moment you install this, starts to audit everything. So if one of your users goes onto one of your file servers, I'm sure I've got a test document here, we'll find out now, and starts editing files, you're going to be able to see that right from here. So if I go into my audit here and I want to search for documents, I can see this audit. Just like the application control, this is a great forensic audit. I can see who opened the program, and not just who, but which program opened it. So in this case, I can see somebody opened the program with Notepad and they read it. Somebody wrote to the program using Notepad. I can see that somebody went off and read that file with Explorer, and then something else tried to read it and it was denied. I'm going to get into why it was denied in a moment. You can see here it was Smart Screen. Now, the reason this is important, if you're about to fire someone for accessing data they shouldn't be or copying data they shouldn't be, and your antivirus just scanned it under their user profile, that's a bad situation. So this is going to tell you which program opened it as well as which user. I can see that I copied this file to my documents folder. The file wasn't encrypted. I can see the serial number of my C drive. It's very important. And then I tried to copy it to a USB drive. Again, drive was not encrypted. I can see the serial number. All of this is logged in real time within a minute. You got an employee, a user sitting in Starbucks. You can come in here and you can see this within a minute of them doing it. If they're offline, it'll upload the logs as soon as they come online. After I copied it to my documents folder, you can see I then deleted the file. And guess what? It was in my documents folder, and that piece of ransomware or that malicious script I showed you in the last demo tried to read it 4 times, but couldn't because of a ring-fencing policy in PowerShell. This is the audit part of the storage. If someone calls you up and says my file's gone missing because I dragged it into another folder, you're going to be able to find out who did that, what folder, and all of the details. Now, that's cool, but what we're really here to see is the policies around this. Now, these policies are incredibly powerful, all of which aim towards that zero trust architecture, deny by default, allow as little as possible. And some of the examples here are amazing. First of all, I'm going to talk to you about a deny USB. This is the most simple policy. Deny read and write access, allow the user to request permission to anything on a USB interface. Somebody tries to open something on a USB drive, it's going to be blocked. They're going to get a pop-up saying you're not allowed to use this USB drive, but you can request access, and the user will be able to request that access. So here, apparently I have a permit policy. I'm going to very quickly delete that, and I'll let that run, and I'll show you that in a moment. So very, very, very simple. I'll get back to that one in a second. We can also do things like a little bit more granular. So I can say, hey, I want to deny read and write access to unencrypted USB drives or USB drives that are not encrypted just based on the encryption status. So if you have healthcare and you're trying to achieve a compliance checkbox, you can do that. When you would do that, just like before, I've said allow the user to request permission. Hopefully I waited long enough. The user gets that deny message. They can request access and you can approve that in 60 seconds. It's really, really easy to say, hey, this user needs this USB drive. I'm going to give them access for the whole computer group based on its serial number. So anyone can use this, and I can just hit permit storage device. The next thing is, you'll see there is it went off and created a policy for that storage device. I can get much more granular. So if you want to block USB drives, but someone in your marketing department comes in and says, well, I've got my digital camera, I need to upload my files. You can go, great, you can use your digital camera. I'm going to permit that, but I don't want you to be able to write data to it. So I'm going to set it to read, and I only want you to be able to write JPEG files to that. So I can limit the amount of things you can do from that perspective. Now, this isn't just about USB drives. We can also do the things like protect documents folder, network shares. Really, really basic example. I've got a backup share here on my folder. It says this is the server, this is the share. I want to permit read and write. But hey, I don't want someone to be able to delete my backup, encrypt my backup, copy my backup, do anything like that. So I'm going to limit it to the program, not just the user. So if somebody tries to access it from Explorer, they're not going to be able to do that. Another example is the QuickBooks share. Don't know if you've heard about this QuickBooks malware that's going around at the moment. Essentially, you open the malware, it does nothing, doesn't encrypt your files, doesn't cause any pop-ups. All it does is take your QuickBooks database, upload it to the web, nothing else. That then gets used in spear phishing campaigns. It gets sold on the dark web, bank details. It gets used for future ransomware attacks because you have relationship details. Hey, here's your invoice that you get from me every single month. Why wouldn't I open it? So the link looks a little bit different. All of this data is incredibly valuable. So you want to protect the share from malware. If you're using the ring fencing, if you're using the right whitelisting, great. But this is just another way that you can stop that bit happening. So you can say here, permit read and write to the QuickBooks share only from these users and only for QuickBooks. So if somebody did manage to run malware, if you did permit it on the whitelist, it wouldn't be able to access that. My public share a little bit wider open. I use it for Office documents. I use it for things like that. So I permit and read and write on these shares, but only for Office and Notepad and Explorer. If somebody tries to use an untrusted program, it's going to get blocked. Whether it's on the whitelist or not, it's not on the list to access that network share. These are really, really effective storage policies that can allow you to harden your environment. We can do things like block DVDs, USB drives. We can deny write access to the desktop. This is my favorite policy of all. As an IT administrator in the past, it drives me insane that people say things on their desktop, it's not backed up, they lose their laptop, and then they go, oh, I didn't know it wasn't backed up, and they're all complaining. So what we do is we say, hey, you can use your PC, but you can't write anything to your desktop. So we just got a simple deny write policy, stop people putting things on their desktop. Really is giving you control. Not all of these controls are going to be used, but they are very, very effective. Things like C dollar shares, admin dollar shares. We all know ransomware loves to transmit via them. You can just deny writing to them. Another really cool feature about the storage control is the remote presence. So great, you have a file server, you have ThreatLocker running on it, and you have all of these policies in place, but someone comes in without ThreatLocker, they can run any program they want. They have a username and password for your file server, they connect to it, and they start encrypting or copying your files. You can shut them down based on other conditions, but it's very, very difficult to control a PC that you don't have. So what you can do is you can put policies in place saying, hey, here's my public folder on my file server. You can read and write this, but only if you're running ThreatLocker. And if you need to make exceptions, so if you have a scanner folder that needs to be accessed from a scan that's not in the network, you can exclude that from it to say all computers, but you can get really granular on who can access these files. Very, very effective tools to harden your environment. Next thing I want to talk about is privileged access management. Administrative permissions, we all know they're bad, we all know they're evil, and people are going to manipulate them, but it's hard to take them away. QuickBooks, if you're an MSP, you have to log onto your client's machine every single month to update QuickBooks. That's a real pain. What we can do is we can allow you to run certain applications as a local administrator. So if somebody tries to run something and they need to run it as an administrator, so I'm going to pick Putty here, for example. I'm going to try and run this as an administrator. And it's going to tell me that I don't have access. So I can request elevation for this application. Same request as the application request and same approval screen. We can see that this is an elevation request, but it's the same principle. I can look at Putty. I can see if ThreatLocker knows what Putty is. Very, very simple. Putty's built in. ThreatLocker's got a definition. I'm going to permit this. I'm going to do this without ring fencing first because I want to show you, again, I know we talked about yesterday how important ring fencing is. I can permit this without any restrictions, and I can allow it to elevate for an hour, for a week. If somebody needs to do something temporarily, I can do that for the entire computer group in this case. So I'm just going to push this out, give that 60 seconds to run, and hopefully that will run. Try one more time here. There you go. So this now ran as an administrator. Very, very seamless. You can also use this if you're using the whitelisting. Somebody requests access to software. Great, but they need admin permissions to install it. So you can give them like 1 hour to install it or something with admin permissions. Here's a problem with privileged access management. If you've ever used any kind of privileged access management or you've used it before, go and test this now. Allow Putty to elevate, browse into the Windows folder and see what happens when I try and run PowerShell. So I'm just going to go into here. I'm going to say Windows PowerShell. I'm going to open this up. And guess what I can do? Even though I'm not a local administrator, I can do what's called application hopping. I'm now in PowerShell as an admin. So if you're using any privileged access management, just test that out. And I want to show you why this happens. You've essentially elevated that process, and that can now elevate anything. It's the way Windows works. Nothing we can do about it. Nothing anyone else can do about it. What we can do is we can ring fence that application. So we can say, hey, Putty, you're allowed to run. You're allowed to be elevated. no reason to elevate PuTTY. But what I'm going to do is I'm going to tell you you're ring fenced, and you cannot talk to any other application unless you've got explicit permission to. So if I need you to talk to PowerShell, which I wouldn't do, I could add that in there. Outside of that, it's not allowed to talk to anything. I'll give that a minute or so to deploy that policy. While I'm waiting for that to deploy, I want to show you a couple of other things. Maintenance schedule. These things are fantastic. We hire a lot of techs. We don't want our techs to be local admins. That's bad. But when you hire a tech and he's got to install 10 apps on his laptop and he's not an admin and you have to go and do it for him, or somebody else in the company has to do it for him, it's a real problem because he can do it himself. It saves time. What we can do is we can create these maintenance schedules. So I can say, hey, I want to turn on a maintenance schedule to allow elevation for 1 hour. And I can just add that schedule. It will turn on elevation. So now as an administrator, I can elevate anything. So I can just go into here and I can say, hey, I can elevate PowerShell because we've allowed anything to elevate in that period. I can do the same with installation mode, learning mode. So if I need to turn off blocking temporarily, I can put on learning mode, put on installation mode, and create those maintenance schedules. It's very, very effective. Next thing, let's just jump back to that PuTTY because I want to show you what happens now that we've ring-fenced that application. Please, anyone who's using privileged access management, go off and try this application hopping. It's absolutely terrifying. And I'm going to close the 100 windows I've opened here. I know I downloaded it here somewhere, and I'm going to run this as an administrator, just like before. And now what I'm going to do is I'm going to go into logging. I'm still running as an administrator, but you'll see when I go into Windows System 32, Windows PowerShell, and if hopefully I waited long enough, we'll find out now, and boom, can't open PowerShell because PuTTY is not allowed to talk to PowerShell. You don't want PuTTY talking to PowerShell, whether it's an admin or not, but you certainly don't want an elevated application to be able to hop to another application and essentially bypass your security. There is a lot of controls here. There's a lot of flexibility here. If you're not already using ThreatLocker, if you are using ThreatLocker and you're not using all of these controls, book an audit review with us. One of the things you'll find about partnering with ThreatLocker is we don't limit the amount of time we'll spend with you. We have 24-hour support, US-based. You can click Get Help from Cyber Hero. You can do a Zoom session at 2 a.m. in the morning to ask about storage control or elevation. We're here 24 hours a day. Schedule something with your engineer. Say, hey, show me about this remote presence. Show me about storage control. Show me how I can improve my system even better. If you are a customer, if you're not a customer, book a demo. It's 45 minutes. We're going to post a link here, but you can go to threatlocker.com. You can book a demo. It's very, very effective. I promise it won't be a waste of your time. Thank you very much, everyone, and I appreciate your time today.